In this lesson, we'll talk about conditionals with Python. So let's start by talking about a new data type called boolean. Python's boolean data type holds true and false values, and it's called bool. If we're running a Python in interactive mode, we could create a variable called b and set it to a literal called true. And if we check its type, we would see bool. In fact, there are two literals, true and false. And these are case sensitive, so the T and the F have to be capitalized. For example, the string true is not a Boolean, and neither is true with a lowercase t. Booleans are named after a British mathematician called George Boole. He lived in the 1800s and was born in 1815. And if you think about that time in the US, Andrew Jackson would have been fighting the British, and there would have been only 18 states in the US. Now, Boole was very poor, and he only had a primary school education. It was largely self-taught. By 16, he was the major earner for his family. By 19, he had his own school. By 29, he had actually won a gold medal from the Royal Society in the UK in math. By 34, he was a professor at University College at Cork. He created Boolean algebra, but sadly he died of pneumonia. Now, George Boole's influence looms large in computer science. It is the basis of all digital logic and computer arithmetic. Now let's look at some operators that will give us back Boolean values. And the first one we'll look at is the equality operator, equal to, and that's used to compare two values. Again, if you were using Python in interactive mode, you might do the following. If you were to print 5 equal to 6, you would get a false because they are not equal. 3 equal to will give you a true. If you were to set j to the string Joe and compare its length to 2, you would obviously get true. Now, the thing you have to be careful about is not to confuse the assignment operator, which is a single equal to, with the equality operator, which is 2 equal to. So we can actually try this out. So let's open a terminal and start Python interactive mode. And we'll set a variable j to be 7. And if we print j equal to 7, you should get a true. But what happens if we make a mistake and say j equal to 7 and only have one equal to sign? You will get an error. It'll be a type error. All right. Now, equal to is not the only comparison operator we have. There are actually 6 in all. Sometimes these are also called relational operators. So let's look at the 6 operators we have. We have equals, which is equal to. We have not equal, which is the exclamation equal to operator. Less than, greater than, less than equal to, or greater than equal to. Note that there are a few combinations where the equal sign appears before the comparison sign that are not allowed. Let's talk about more operators that give us Boolean values. Logical operators, 3 of which we'll talk about, are and, or, and not. That will also give us Boolean values. So let's talk about these. The and operator takes 2 operands on either side, which could be values or expressions, and returns true if both are true. The or operator will return true if either is true. And not takes 1 operand and gives us the opposite. If it's true, it gives a false, and if it's false, it gives us a true. Now, these operators are sometimes easily understood if you create a truth table that is used in computer science quite often. So you have 2 operands, x and y, and you will notice that x and y is only true if both are true and is false otherwise. X or y is true mostly except when both are false. Not of x basically negates the value of x, and not of y basically negates the value of y. Now we can use all the operators that we know about to create an expression that would return a Boolean value. And such an expression is called a Boolean expression. So let's take an example. As an example, consider the linear range where x is between 4 inclusive and x exclusive. And it might be represented linearly like this with a solid dot at the 4 and a hollow dot at the 8. Now, how would you represent it as a Boolean expression? You'd represent it as follows, where x is less than or equal to 4 and x is less than 8. This represents this linear line. Now let's take another example that comes up very often. How would you represent n is divisible by 3 or divisible by 2? Right? Those are the two values that are given to us. Now let's take this in part. We use the modulo operator, percent in Python, to return the remainder of an integer division of dividing two numbers and with the remainder. For example, if you were to divide 27 by 4, the remainder is 3. And if you use the modulo operator, that's exactly what it gives us. So obviously, if the modulo operator gives us a 0, it's cleanly divisible. So the expression n modulo 2 is equal to 0 represents that n is divisible by 2. So the expression n modulo 2 equal to 0 or n modulo 3 equal to 0 represents n being divisible by 2 or 3. Now let's talk about a little bit about the not operator. So not negates the operand that you're passing in. So not x greater than y is the same as x less than or equal to y. And sometimes it is better to use this format as it is easier to understand than something with a not. Let's take another example. Note that n is 5, 6, or 7 is not equivalent to this expression, n equal to 5 or 6 or 7. It should really be n equal to 5 or n equal to 6 or n equal to 7. Now, a very tricky pitfall is the following. Let's actually try this out in our interpreter. So this is going to be very interesting. Now, if you say j is equal to 0.1 plus 0.2, and then later on we say print j is equal to 0.3, you would expect this to be true because 0.1 and 0.2 should be 0.3. Now you look at it and it is false, which is very, very strange. Now, how could this possibly be? And the reason is that decimal or floating point arithmetic, by definition in computer systems, is not precise. An approximation is used for decimals. So if you were to look at j, what it represents, it is very, very close to 3, but it is not quite 3. And the rounding errors and the little bit of errors, they do add up. So be really careful in doing these kind of comparisons in your Boolean expressions. Okay. So now we will talk about an actual construct that allows us to do conditional execution. So far what we know in Python is we have statements that execute one after another. But sometimes we want to make a decision. Sometimes based on some condition, we want to go to one path of statements or we want to go to another path of statements. And that's kind of what is represented by this flow diagram, where you check some condition that is at runtime, and if it is true, you do one set of statements. If it's false, you do another set of statements, and then you continue. Now, this is called conditional execution. And this decision here is actually represented by a Boolean expression, because a Boolean expression will return true or false. So the construct in Python that allows us to do this in most straightforward way is called an if statement. And so let's take a look at that. So this new if statement has the following form. There is a new keyword called if, followed by a Boolean expression. Then there's a colon. It's followed by a set of statements. Then there is a new keyword called else, and then it's followed by a colon, and then there are statements here. So let's take this in part. The Boolean expression here is called a condition. If the condition is true, these statements are executed. If it's false, then these statements are executed. Now these statements are also called a block, right? And so this is the if block, and this is the else block. A block can contain one or more statements. Now, as I've already said, that you evaluate this expression. If it's true, you do this block. Otherwise, you do this other block. Now note that if and else are new keywords that we've been introduced to, so you can't use them as variable names. Do note the colon, the placement of the colons. So let's take an actual example so we can understand this better. What would this actually look like in code? So in code, it might look like something like this. If followed by a Boolean expression. Let's assume that there is a variable called age. If age is greater than or equal to 21, then it prints one thing. If it is otherwise, it prints another statement. Now this type of if statement is called a binary selection because you can take two paths. If the condition is true, you go one way, and if it's false, you go another way. Now you can optionally skip the else clause, and then it becomes a unary selection. So you can have something like this. If age is less than 21, and then you print two statements here. Now do compare it to this code fragment here, where you will notice that the second print statement is not indented. That means it doesn't belong to the if block and will always be printed. So be careful with your indentation. So that's a good point to talk about some pitfalls of doing this. So there are three particular cases that I want to talk about. The first one is what happens if you have a missing colon. So let's actually try this out in IntelliJ and see what happens. So we will open up IntelliJ and paste that here. Now it will give you some kind of a warning, but I want you to try out and see what kind of error do you actually see. And here you will see it gives you a nice syntax error. The other thing I'd like you to try out is what happens when you have multiple else. Now you could only allow it to have one else. So having multiple else's is a problem. So let's take a copy of that and try that out in IntelliJ and see what happens. Now IntelliJ will gives you a warning, but I'm more interested in what happens if you actually try this out. And again, it gives you a syntax error, not particularly helpful, but at least it gives you practice in what kind of things you might be seeing. The last thing I want to see is what happens when our indentation is a little bit off. It's uneven indentation. So let's take this example and try this out in IntelliJ, and let's see what kind of error we get. And here we get a very nice error where we get an indentation error, and we see an unexpected indent, and it points us to something to look at. We will continue to talk about some more complicated conditionals. Now note that the if block or the else block could itself contain further if statements. You could have a nested if statement. So let's consider the following piece of code that compares two variables and prints which is smaller. Now the easiest way to do this is, of course, create the variables, and then you check if x is less than y. You say x is smaller, and then you have the other condition where y is smaller or they're both equal to, and this is kind of how you would represent it. So now you notice that in the else block you have a further if else statement, right? So you can imagine this gets confusing, which else belongs to which if. And this is all determined by the indentation. Now, but this can be hard to read and confusing, so Python provides this thing called chained representation, which looks a lot more intuitive. So it will look something like this. You would have if x is less than y, you say x is smaller. Then you have this new keyword, a new representation called ELIF, else if y is less than 0, then you print this, else you put, say, that these are equal. So let's talk about this a little bit. There's a new keyword called ELFI, which is an abbreviation for else if. You can have multiple else if blocks, but you can only have one else, right? So in a change statement, you basically are going down and checking each Boolean expression, and the first one that is true, you execute the corresponding block, and then the whole if statement stops. So it's very, very clean and very, very easy to understand this kind of representation. A few more things I want you to learn here is generating random numbers. Sometimes we need to do that for our program and for testing, and for that we need to import this module or library called random. And the easiest one to use is something called random.randint with two parameters passed in called a and b, and gives you a random number within a and b, both a and b inclusive. So if you were running this, it'll give you a random number between a and b with 1 and 100 with 100 inclusive. We can actually try this out. This might be actually kind of interesting to try out. So here we will do this, and let's actually run this a few times and see what it prints on 81. If you keep on running this, you'll see you'll get different random numbers. The other thing I want to talk about is stopping the program. So now you know conditionals, so you can conditionally do things in your program. And suppose you detect an error condition and you want to stop the program. How do you do it? And there is this function called exit that'll stop your program. So here's an example. If some value is negative and you were expecting it to be positive, you might print an error message and exit the program. So actually, we could actually try this out. So we can go to PyCharm and do this now. Of course, val needs a value. So we go to val and let's just set this to be some positive value. And we'll go here and we will say print done. And in this case, it is not negative, so it will probably print a done. But if you were to set this to -5, it'll detect that as a negative value and say bad data and exit. All right. So this has been a lesson on conditionals. Thank you.